how to model almost anything, exercise 2. So make sure you have your PDF open and we will walk through what this is looking for. So the first thing is it's going to talk about a bike, and it's going to go through that CAD file. So the first thing you're going to do is open that cool bike top assembly and then talk about it. So if you just did exercise 1, you probably have the sub or the glider or another model open. Now it's important to understand that you should close. You can use that, or you could do this. You have to close. Now this does not erase the model. It just erases what you see. In the memory, we still have all these parts, and you don't want that to conflict with your new model. So you must, at the end of closing everyone, make sure you erased the not displayed items. So make sure that's done, and now you're ready to go. So let's actually look at that real quick one more time. We close and then erase. Make sure that you do that. That is important. So let's go open our cool bike. Open top assembly, and you have this piece. Now the first thing it tells you to do is get rid of these displays. Mine was actually already defaulted off. So you get rid of the display, and you have this cool looking bike. Now, excuse me, it goes through the process of making a solid model. So you're going to start with essentially a two-dimensional shape, and you're going to actually do something called extrusion. So you're going to take a two-dimensional shape, a two-dimensional area, and you're going to drag it into the third dimension to create a 3D object. So this object started as this two-dimensional cross area and cross section, and extruded it in this dimension to give you a three-dimensional view. So that's how this bike was made. They made at first this easier, simplistic, more basic view, and then they did all these commands to it. And this section goes through that whole process. So one option, one process, one step would be having this shape and then subtracting this shape from it to go towards this. And so this whole section walks you through that. For example, if you had two circles and you join them, you would have kind of a binocular view. Or if you subtract them, you get something that looks more like a crescent or a moon. And that's generally how these shapes are made. And it goes through a couple rules. You have to have a good cross section, which means that you can't have any openings and you shouldn't have any dangling edges. And so you have to make sure that your model is good before kind of going through these steps. Now these steps that you can do, you can extrude, which is basically pulling in one direction, or you can revolve. Now if you look carefully, this is actually the same two-dimensional cross-sectional area. We just picked a radius and then revolved that shape around to get something that looks like this. You could also take the same shape minus the hole that was drilled out from it and sweep across a curve. So you could define a curve and say, I want this piece to sweep around this curve to create a more complicated shape. Or you could essentially blend it, which is taking two or more cross sections and blending them together along a curve. So a much more complicated way of thinking about these things. You have to break down your 3D shape and think about how you can make it from a 2D shape. And essentially, that's what you have. So back to what we should be doing. So that's kind of a background of how these parts are made. Now, so we want to open the cool bike frame. So we'll go over here and we'll open the cool bike frame, and I'll drag it into view so you can see everything that I'm doing. And so look at, we got a nice little frame here. Now this frame is generated by a list of instructions. So you start with an original geometry, and then you do a bunch of operations to that geometry, and then you end up getting this piece. The whole point of everything that is talking about here is for you to understand that this is a list of commands. And so if we take this insert here function, which is kind of like a viewing now function, we can actually change. So let's look. So you have chamfer here. We have this, which is targeting kind of these operations here for where the handlebars are mounted. we can actually take a look at what it looks like before that step is done. And so if you look at the holes here, they are actually not chamfered anymore. Now chamfered is a type of kind of a finish. And so you can make a groove, you can round off an edge, or you can chamfer, which is kind of like cutting off the sharpness to it. You create a draft angle, and so on. So you can take a look, basically by moving the insert here, you can go back and forth kind of in time for this part. And so we can actually backtrack further when there was no handlebar mounts, or we can even go further when there wasn't essentially a seat hole, which is still there, which is interesting. But we can keep going back and forth and getting back to the original piece. So what it wants you to do is go to the original piece and see this for yourself. So I want you to go through, I want you to edit definitions, and look at this. Interesting. That is, let's edit. We want to edit definition. And hold on one sec. Let's go back. I totally messed everything up. Okay. Let's just close and not save any of this. And erase not displayed, remember that? And let's go back to where we were. Instead of trying to find out what I did, it's probably easier just to start back from where we were. Okay, back to this shape. We're going to take a look at the original shape, and from that we are going to edit definition. Still, oh, we have to do it on the section, right? Interesting. Cancel what I'm doing. Edit definition on the section. There we go. Okay. So I don't want to actually edit the definition on the entire extrusion. I want to edit the definition on this two-dimensional section. So this is a two-dimensional area, which is actually an isometric drawing if you remember from last semester. And so you have all of these points, you have all of the lengths, all of the distances, all of the radius information, every single little piece to making this two-dimensional shape is present here. So you can see how this part started. We're going to cancel, we're not going to change anything again. And essentially it wants you then to take a look at further. So we're going to take this two-dimensional shape and we're actually going to extrude a piece out of it. We're actually going to take out that geometry and get closer and closer to what this looks at. And then you can look at definitions of that, and you can look at sizes of that, and what other information you need. But that's the main point, is you have the ability to go back kind of in time and see what the part looked like originally and make any changes you want. Now, one of the more powerful features of this software is its actual ability to do simulations. So we can take a look at this part and say, hey, let's go let's prepare the part, let's go to material properties, and let's take a look at what type of material this part is made out of. Let's say we want to make the bike frame out of aluminum. So you can make it out of this type of aluminum, which is the material in the model, and we can actually select the properties of that aluminum, and there you go. You have density of aluminum, you have Poisson's ratio, which has to do with if you stretch it, how much it kind of decreases in size in the other dimension, and then Young's modulus, so we can do stress and strain calculations, coefficient of thermal expansion, how hot, when this thing gets hot, how big does it get, and you can do further thermal calculations and so on and so forth. So you can actually do a bunch of different calculations with this. And what's nice is now you have this very complicated geometry, and you have a way to calculate how this geometry is going to perform. And very, very helpful, especially for us, making wings and kind of what material we can make it out of, and then we can figure out, how strong is this device, or where is the center of gravity acting, and essentially pretty neat. A good way to calculate forces or any other information that would be otherwise very, very cumbersome to kind of come up with. So we have all these material properties, and you can see them, you can select them. Menus are slightly different than what we have, and it's going back again to rendering and colors. Now, we do not have a school tab in the version that I have here, but you can see that it's display group, which is like view, right? So if we go to view, we can find our appearance gallery here. We can select whatever colors we want. So let's say green, and I can select a piece and say I want that to be green. Now if I hold Control, I can select multiple surfaces and change the color of that area. Or I don't have to. So you have that features. Now that's important because one of the main benefits to using this is you can also render more or less realistic looking environments. You can see how big is this object, what does it look like next to other things, which is pretty effective if you're trying to make a sales pitch or presenting to a school committee, for example. So pretty neat. Now another thing is you can export these videos or these graphics to other software as well, and they can go from there. This you don't really need to do, but it just talks about moving that insert here arrow, which is kind of like a present versus past of the model, and kind of bounce around to the first extrusion where you had a cylindrical solid where you cut out a middle piece of it, and then you added a chamfer, so you had this little ring is edged, and then you essentially revolved another piece to remove kind of like the rim area, and then you can add these little extrusions. So it shows you how the part is rendered. Now another interesting thing, kind of the third part that's important to understand about this, is device parameters. Now one of the very nice things about Creo and CAD software in general is you can make edits to it pretty quickly and pretty easily. So for example, this right here, this is where the handlebars mount to our piece. So let's say that we have a very tall person riding it and we want to be able to change where these handlebar locations are. We can do that, which is pretty nice because it will not take long at all. And so we can go ahead and edit this piece. We can go ahead and edit it, and it will, without changing the name, there we go, we will edit, and it tells us information about it. So you could go ahead and change the radius if you felt like it, or we can change the location. So for I'll tell person we don't want to change the radius, we want to change how far it is from this data line here. So instead of 6 units, which is probably centimeters, not sure, 6 inches, I'm not sure, we can change it to 8, and you should see the part then slide forward, and now that dimension is 8 away from that departing line. Pretty quick, pretty easy, and we can close this, and now our model is actually changed. And so where these mounting holes should align here, but they don't, you can see that we've slid that part forward. And so you're probably thinking, well, that's kind of useless, right? Now I have to redo this. But if we actually regenerate the model, which means go through the commands again, we can actually fix that. And so now the lines, now it all fits, and we've made adjustment to our three-dimensional model very quickly, very easily. And so that's what this is telling you. So that's the regenerate feature, and that's what you get. So yeah, that's basically what you have. And so you have a couple questions again to answer, and a couple questions again, and then also you should go through these and create your own screenshots. And that is the end.